So what do these currents actually do? Why is it important to know about these currents? One aspect is the heat transport in western boundary. Okay, and here's one example of you can see the heat transport. Shown here is the sea surface temperature derived from satellite observations on the east coast of Australia, and the orange water refers to water warmer than 22 degrees Celsius. And you can see that there is a tongue of orange-red water extending all the way down along the coast. So all along this coast here, this is where the mouse is activated now, is the current moving warmer water into a colder ambient ocean. This is what we call heat advection, and the most prominent example of how it can influence the climate is actually in the North Atlantic. The Gulf Stream, there is an extension, which is the North Atlantic current, is actually responsible for heating up the Northwest Europe, making it on average 7 degrees Celsius warmer compared to the same latitude in North America. So this is impressive stuff, isn't it? So the western boundary currents play an important role in the regulation of climate on Earth through heat advection. They also create a mesoscale eddies. Mesoscale refers to a scale of 100 kilometers. And eddies will be discussed. They also play an important role. It's also indeed in the heat exchange of heat between the western boundary current and the ambient region. So now, also the variability of these western boundary currents can cause heat waves, marine heat waves. So you can just look at this example here and imagine that you move this red water further to the south, and you can create a significant marine heat waves in an area here further to the south, with having events of where the temperature is 3 or 4 degrees warmer than usual. And indeed, this can have dramatic consequences for the marine and environment. Yeah. So now the second aspect is that these currents can actually transport particles, objects, floating objects, or marine animals. You can move all the way down from the north to the south, taking advantage of the East Australian current. The speed of a western boundary current is a meter per second. So how long does it take to travel from north to south along this section? Okay, so what you need to know is, what is the distance? Do you know what the distance is here? Can you tell me what your neighbor comes knocking. Hey, what's the distance along this here? How many? This is 2, 4, 6, 8, 10 degrees. What's the distance? Oh, wow. It's 1,000 kilometers. It's easy, isn't it? So how long does it take if you're in a current of 1 meter per second speed to travel along a distance of 1,000 kilometers? Yeah, tell us. The neighbor comes. Hey, how long does it take? Okay, we answer that question. We're going to answer that question. And you can, and that's why you are studying at a university. You will answer this question. Okay.